Okay, hello everyone. Hopefully you guys have scanned the QR code, and if you want to join the makeup exam, please scan this QR code. Okay, and again, the makeup exam is on 25th of December from 10 to 12 in the morning. And it is on TR 309. Okay, I think we can start. Uh, for today, I will continue chapter 6. Okay, just a little bit more. Uh, Before we start, let me a little bit review. Okay? So first is we have area between curves, right? Finding area like this, and then have another one like this, and you have the area. Then we have a volume. We call this is the this method. Because our volume is on the disk, right? And we have to find this radius here. Okay? And still on the volume, we also have for example, like that. Let's say it's rotated through here. Now, I've made a mistake on the terms. Okay, so the washer method is this one. Okay, sorry. This is the washer method. So the idea is to compute or uh, the difference on the area. So this is, let's say, R1, this is R2. We need to compute the difference on the area, the circle with the radius R2 and the circle with the radius R1. Okay, so we have three sections: area, volume, the disk method, and the washer method. And the next one should be the another method for evaluate the volume. Okay. We start from this problem. Okay, we start from this problem. We have this equations: y equals 2x squared minus x cubed, and we need to rotate uh, about y-axis. So we rotate about y-axis. So the difficulty here is we are not sure the radius, okay? Because the radius for both cases, it seems they are changing, right? And then if we have this using dy, um, it seems it's not really becoming a washer, a complete washer, right? Because if you imagine at the top here, uh, they are basically gone, right? Now we need to have another approach, okay? Another approach with another geometry approach. So what we are going to do is let's have uh, this rectangle here. Okay. Okay. And let's rotate about y-axis. Okay. If I take this samples, the geometric samples, okay, it will be like like this one. Okay. It has a thickness. Okay. Let's call the thickness delta R. Okay. And the outside radius is R2. The inside radius is R1. Okay. And the R, this R on the left is the average R. This R here is the average R in between of R1 and R2. Okay, so it's on this middle distance. Okay, it's uh, and it's having the height h. Okay, the height h. Okay. Now let's try to break down our volume from this geometry. Okay, so the volume is the volume 2 minus volume 1, which means the volume 2 is the cylinder with the R2, okay, and volume 1 is the cylinder with the radius 1, R1. Okay, okay. take this into the formula, this will be pi r2 and then squared, and then multiply by the height, right? Minus pi r1 and multiply with height. We have the same height, so we can calculate this become okay. Okay, now let's take some algebra to finish this. So if this is a squared minus b squared, we can have a plus b, a minus b, right? So let's just do that to our radius. So volume r2 plus r1, r2 minus r1. Okay. Okay. Let's take some assumptions. Okay. Let's assume that the delta r is the difference between the r2 and r1, right? And then the r, or the average here, this r here, let's make this as half of the r2 plus r1, the average, or let me write here the average radius. So you can write pi h r2 plus r1. We should have half, so we need to multiply by 2, right? So 2, and let me write like that. Let me write one by one. So volume 2 pi h, or let me write r first and then h, okay? And then delta r. Now this is a new geometrical approach to evaluate the volume. And to make it familiar, if you want to maybe memorize, this is the circumference, okay? The circumference, height, and thickness. And of course, it can be applied to dy or dx. Okay, depends on the situation. So you can exchange the delta r to dy or the dx. Depends on the situation. Okay. Okay. Now let's continue a little bit. This is we call the cylindrical shell method. We continue to the next section. And let's say we have this graph here. Okay. If you want to rotate through the y-axis, this is what we get. And of course, if we are using uh, the cylindrical shell, it can be evaluated. Okay. And in more uh, more details, we can also look at this. So we can take the picture here, and let me put this around. So this is this shell method. This is the geometric samples. We take the sample x here as our delta. Okay. And if we cut this volume into several parts and become smaller and smaller, okay, from A to B, and we want to evaluate from A to B, then in terms of the sum or the approximations, we can have this is going to have to be sum from 2 pi xi sample, and then sorry, f, and then delta x. And then as n getting bigger, as n getting larger, the volume becomes, we can evaluate through the limit. And we can take this approach to our integration from A to B, 2 pi x f of x dx. And then the better way to visualize how it looks like is if we cut open, if you cut open this, the shell method, if we cut this, okay, and we take the shell into a rectangle shape like this, we'll have precisely the longer line here is the circumference, right? The circumference. Or we are going to have the 2 pi x, okay, right? The radius is x. The thickness is the delta x, and the height is the f of x. Okay. So again, the key points is identify the radius. So key is identify radius. Identify radius. Identify the function. So volume is circumference multiplied with height multiplied with the thickness. Okay. Okay. Now let's take this approach to evaluate our first problem. Our first problem is this, right? So let's take the shell method to evaluate this. Okay. So let's say we have a region bounded by, so region bounded by y to x squared minus x cubed and y equals 0. Okay. So from our perspective, we are going to have a shell on this one. Okay. So we need to identify the radius. Okay. So this will be our radius, right? So let's say this is our r, and this will be x, right? And our evaluated point is 0 and 2. Okay. So volume, or if I want to write in more details, this will be the f of x. Okay. And we have the x here. The thickness is the x. Okay. So the volume will be integration from 0 to 2, 2 pi x. Okay. And then the height is 2x squared minus x cubed, and then the x. Okay. Again, if we are going to break down this is our circumference, this is our height, this is our thickness. Okay. We can evaluate this and multiply the x, and then let's integrate. Two with the power 4, 8, right? Okay. So minus 232 over 5. And this will be 8, 8 over 5, right? So 8 to 16. So this will be the results. If you want to know the how it looks like on the 3D shape, this will be the picture. Okay, so that will be how it looks like, the volume. Okay, let me give you some examples. I will give you some examples, and I think we can finish chapter 6, I think, by today. because I will skip one section on chapter 6. Okay, let's say the example. Find the volume of the solid obtained by rotating about y-axis the region between y equal x and y equal x squared. Okay. By the way, if you want to take the QR code, okay, please scan the QR code here. Oh, wait. If this is better using this or no? Oh, brighter, right? Okay. Okay. And if you wanted to join the makeup exam, you can scan the bottom one here. And let me again inform you that the makeup exam on Saturday, 25th of December from 10 a.m. to 12 a.m. Okay. The place is TR309. So we don't really have other schedule. So this is the only available schedule, I think. So if you want to join, you can join with this QR code, or later I will also attach the link in the Moodle. Okay. Okay. Let me just continue. Okay. Okay, we can take the graph. We graph first. Okay. And as we know, and we already have this many example, that this will be 1, 1, this will be 0, 0. So the region is in the between these two curves. So we want to take this shape here. We rotate through y-axis like that. Let's rotate through that. Okay, and using the shell method, so the volume will be evaluate from 0 to 1. And again, this will be x. Because it will be changing every time that it's variable x, right? So 2 pi x. And then the height will be x minus x squared. Oh, sorry, I forgot to mention y squared. And then the x. And the volume, 2 pi. And integrate this. Or this is 1 over 12, right? And then this will be pi over 6. So you have several options now, several options, right? You can use this method in some way. You can use also the washer if it has like this one, like a hole, and you can also use this cylindrical shell method. So if you look here, the shell method is, I think, it can be used in more curves, okay? Because if you have a curve that is like this, and you need to rotate through here, definitely you need to use this shell method, okay, if you have this. Okay. Or if you have the other one like this and rotate through here, rotate through here, it's also using the shell, right? So every time you have curve like that, you will notice that, okay, I need to use this shell. Okay? The this or washer will not work out. Okay? But for other curves, the shell method can also be used. Okay, you can use it like for this one, like the same example as the previous one, right? The x and x squared. Okay, I think I can give you one more example. And sometimes if you can choose between this or the shell, sometimes the shell can be more easier. Sometimes this can be more easier. The calculations, so you can choose which one. But those two methods will have the same result. Yeah, same result. Okay. Okay. Let me continue for another example. Okay. Another example. Find volume of solid obtained by rotating region bounded by x minus x squared and y equals 0. Rotate about line x equal to. And again, the key to solve most of area or volume in the integral, or especially the volume, is first sketch the graph, of course, to imagine how it looks like. The second one, find the radius, identify the radius, and identify the functions, which one you are going to use, dy or dx. Okay. After you finish all those three, the calculation, I think it will be simple. It will be simple, the calculation. Okay. Now this, if we want to draw, okay, 0, 1, probably 1 is here, 2 is here, 2. And let's say that's our curve. This is x equal to, rotate through here, and let's take this sample here. Okay, so let's take this shell method. Let's use the shell method. So our radius will be from the center x equal to our sample here, the rectangle, right? This is our radius. Okay. Now what is our radius here? The radius for our shell method. Let's now we are not rotating through y or x axis. So we need to have another value, right? Okay. So if you start from 0, this is 0, this is 1. Okay. If you start from 0, x equals 0, if we move to here, it can be anywhere, right? The rectangle. So it's all the variable x, right? So we can write this as x. Okay. We write this as x. And this one will be 2 minus x, right? Okay. Because this is x equals 2. So our radius that we want to apply into our calculation will be 2 minus x. Okay. And we can write down this is the formula for the shell. It's from 0 to 1 to pi. The radius is 2 minus x. Okay. The function is x minus x squared. Okay. I'm going to solve this. This will be x cubed minus x squared minus 2x squared plus 2x. So this will be x cubed minus 3x squared plus 2x dx. Okay. It's pi over 2. Okay, so I think for the practice and exercise and some examples, I think I will leave it to your uh, DA, and also I will give you the several exercise for from the area between curves and the volumes. Okay. Okay. Uh, we have so 6.1, 6.2, 6.3, right? This is our chapters. So this is the area between curves. This is volume, this method, right? This is also volume, this shell. We have 6.4. We will skip this. Okay. No, no, we will not elaborate this. It's the work about work. So we skip that. We're going to go to 6.5, the average value. The average value and mean value theorem for integral. I will leave the work on the physics part because most of the problem is physics problem. Okay, maybe any questions first before we finish the average value. Okay. Any question? Maybe the online students, if you have any questions, you can also asking. If we have time, maybe another week we will have some exercise on chapter 6. But if not, then we can focus on next chapter. You can practice by yourself, and maybe you can ask if you have difficulty, which problem you have difficulty, I can help with. And maybe I will add, as usual, maybe another video for practice. And we will have how many days left? So today 20, Friday we still have a course. Next Monday we still have 27, right? But Friday I think 31, right? 31 is holiday, right? Okay. But after the new year, I think we still have at least maybe one or two meetings. Okay, but it's up to you if you want to have the class or not. But it will be online class, okay? So you don't need to come. And I will also need to have if you already have schedule for final for other courses, okay? Please let me know. We can decide when we will have our final exam. Because in my default schedule, we can have the final a little bit late, maybe around from 12 to 14. Okay, from 12 to 14 around that day. So it depends on your other schedule. If we can maybe have early, maybe we can have early, maybe from 9, 9 or 10 also okay. But we can discuss next week, okay? Maybe on next Monday, okay? We can have discuss when we will have the final exam. Okay? And I think we can just uh, the chapters maybe until chapter 7, maybe. Okay, if we don't have really much time left for chapter 8. Chapter 8 is actually short chapters, so I think we still can do it if we want. Okay, if we want. Okay. Okay. Let's go to the 6.5, the average value. So first is what is average? Okay, what is average? Average means if you have a data set from A1, A2 until A10, and you know that the frequency or the how many data set is 10, right? The average value will be A1 plus A2 plus plus A10 divided by 10, right? This is a common knowledge, right? So if we have uh, y average. This is y1 plus y2 plus y3 plus until yn, and we can divide all this with the frequency, how many n it is. Okay. And if we exchange this into y equal f of x, so if this is x1, we take the sample point, x2, and adding until some n, and we divide this with n. This will be also our average. Okay, and remember also in the approximations, the sum, okay, or the Riemann sum, we know that the delta x, okay, if we have the functions, if the functions we have, this is, let's say, f of x from a to b, and you want to have to cut this into some rectangle, and you know this is the delta x, and we can have the delta x as b minus a divided by n, right? Now let's write n in terms of delta x. So n will be b minus a over delta x, right? So let's exchange this n to here. Okay. So this will be b minus a over delta x, or we can write y average. We can write 1 over b minus a, and then we can write down the f and then multiply with the delta x. Okay. And then the middle part is our sum. Let's write down the sum. Okay, you can write like that. So our average we can write as the limit as n getting larger, or you can write down in terms of integral definitions. Now this will be our conclusions. Okay, so this is the average value of a function. So average value. Average value of a function on interval AB. Okay. Now using this average value, okay, into the mean value theorem in integrations, meaning that this average value is we use this average value as a C between AB. Okay, if you remember the mean value before, so we can also write the mean value theorem for this average value. But let me just wait for you to take some notes for a few minutes. Okay. Okay. And let me move a bit here. Okay. So mean value theorem and integral. So if a function is, let's say the functions f, okay, is continue on AB, then exists a number C in interval AB that is FC is equal F average, or we can write down our formula for average value. Okay, of course, right? It's logically and reasonably correct, right? Because this value here is in between A and B, right? Okay, and we can write down that the A, B, fx dx is equal. Okay, and that's it. The chapter six. Chapter six finished. More or less, how we are going to use this theorem is if we want to take some proof. Okay, take some proof. Uh, if we have or finding the C, what is C when the uh, when we have some several value of the integrations, okay, and maybe we need to prove whether the C is on between A, B, or not, okay, or proving some statement, we can prove also using the mean value theorem. And I think if you can remember this part, I think this should be okay. This is the average value part, and we know that the average value, the C, will in the between A, B. Okay. Okay. So the next section is actually I will move to chapter 7, which is the technique in integrations, and I hope we can have sufficient time, okay, for chapter 7 from this today and Friday. And since chapter 6 is finished, we may have another quiz. We may have another quiz. But I think it also depends on you, okay? If we have like quiz at least having quiz 1, 2, 3, and we have already 4, right? For quiz, remember? No, 4, right? The limit, the derivative, the online quiz, right? Limit, derivative, and then oh, 3. Oh, only 3. Yeah. If you feel okay with your quiz, then we can just have 3. But if you want to have another one, we will have the chapter 6. What do you want? What do you think? Do you think we? Oh, there is one student say okay, one more quiz. Do you think it's okay? Yeah, probably next Monday. Probably next Monday, chapter 6. We will have like last time, maybe 40 minutes. So maybe around 2 or 3 questions probably. 3 questions, yeah. So I will finish the chapter 7 today, Friday, and next Monday. And another video for chapter 6 I will provide, okay? So you can have practice, and maybe I will also give you some exercise, okay? And I think some students let me know that if I can show which part in the exercise that maybe you need to work on, maybe um, what is the interesting part on this exercise that can help you. I think I can also do that as well. So I can highlight some problems for you. Okay. Okay. So let's move on to chapter 7. Okay. Chapter 7. Let me check. The first one is okay. We start from it's called the techniques of integrations. The first section is about we call the integration by parts. Okay. The first session here, we need to consider, let's say uh, the big F like that is equal small f and g. Let's say we have this function. Okay. if we are going to differentiate this, we will have f prime g plus g prime f, right? Okay. Or we can write this as this is d dx of f and multiply with g. Mm, let me write in a clear way. Okay, let me write that. And then d dx of g. And then multiply by f. Okay. And we can also write this f in terms of fg, right? Okay. Okay, let me take okay. Um, Now take the integral, take the integral, take the integral. Okay. The left side, by fundamental of calculus, theory of calculus, this integral and d dx will remove, right? We can remove this. Okay. So this will be fg equal this will be let's write integral g df, right? This g df, this is df, okay, and plus integral f dg. This will be dg. And we can rewrite the form here. Okay. Now, if we have the u is function of x, okay, and v is g of x, we will have du is fx dx, and dv is gx dx. Okay, and then the formula here will be if we write this part. So let me write it again here. We can write this dg as actually as in terms function of x, and then dg becomes oh sorry, should be prime here. Okay. Okay. So this is or dg. So g prime x dx equal, and then minus g of x, and then f prime x dx. So you can write this in terms of u, and then dv equal u v minus v d. So we call this integration by parts. Okay, what's the idea behind the integration by parts? We need to identify which one is u, which one is dv from our set of integral. Okay, and when we have u and dv each has functions, then we can set this formula, and then hopefully we can find the solution from this formula, from this setup. Okay, so it is started from to begin with. It start from the product rule. Okay, the product rule. Start from product rule, and then with uh, some exchange, and we can rewrite the forms. It's become the fg equal integral gdf plus integral fdg, and we can switch the sides, and we write in terms of integral fdg. Okay, or we can write also with in terms of u and v. And in most cases, integration by parts is, I think, can solve most of the problem. So the first method you have is substitutions, integration by parts. Okay. And also, aside from substitutions, you can also try some guesses. Okay, try some guesses. You can also calculate faster with the guesses. Okay. And I think the formula is best fit with these terms, right? I believe most of you learn the integration by parts with this formula, right? UV, UDV, UV, VDU, right? Okay, so if, for example, okay, if we want to integrate ln x dx, okay, if we set u is ln x, du will be 1 over x, right? Dv is dx, and v is x, right? So we can set up this comes uv will be ln x, x ln x, minus vdu is x 1 over x dx, right? Sorry. And we cancel this, and this will result x ln x minus, this is 1, so it's become x plus c. Okay. So first we set up the ln x as u. This is dv. So we need to find from this u dv, we need to find du. We find du here. U ln x du is 1 over x dx. We already have dv is dx. We integrate dv, become x. Okay. Okay, let me give you a few examples, and maybe if we have time, how to simplify this method. Okay. Okay, let's take the example. Let's start from x sine x dx. Oh, this one. Okay. Which one? This or this? This one here. Okay. Okay. Let's try x sine x. So you can have several way, right? You can have several combinations of u and dv, right? That you can choose, and you can try which one is better or which one is more simple, right? Because both, like if you divide like become x and sine x, both can be differentiated, both can be integrable easily, right? Usually, the idea is if you can derive and you cannot integrate, then that will be your u. And if you can maybe easily integrate, then maybe that will be dv. Okay. So, for example, in this case, if we let the x is u, okay, and dv is sine x dx, then this will be resulted, du will be dx, and v will be integral of sine x is negative cos x, right? So we can write down the setup for our integral become minus x cos x minus, this will be uh, v du minus cos x dx, or this will be minus x cos x plus sine x, right? Plus c. Don't forget plus c, okay? Don't forget plus c. I think on the quiz, the integral, some students miss out the plus c, so you don't. We will not get a full point if you miss the plus c, plus constant. Okay, let's try another example. Let's try e with power of x. So we have e with power of x and sine x as are your functions or your integral that you need to evaluate. Okay. Now the problem is uh, for e, you want to derive or integrate is still e, right? So there's some tricks to solve this one. Still, we use the integration by parts, we still use this method, the integration by parts, but there's some tricks to solve this. Let's try this one. I'll give you maybe 1 or 2 minutes to try. If you are not careful, okay, when you solve this e, you'll get the endless integrals. Yeah, integrals, right? You will, because e, we integrate e, right? Sine, we get sine cos, sine cos, sine cos, right? So if we have uh, integral u dv, let me write here. Okay, integral u dv equal uv. Okay, if you are doing this, we still have this integral. We integrate again, and I think if we still have e and sine or cos, it will have another integration by parts, right? And it will be endless. So how to do it? First, okay, we need to write carefully. Okay, so first, if we have u is u with power of x, okay, we have du is dx dx, and if we have dphi is sine x dx, this phi is minus cos x, right? Okay. Now first, write down every time you solve the integration by parts, always write the questions on the left. Okay, you will see why. You will see why in this type. Okay, so first, let me write this will be u phi and minus because it's minus cos, I will write plus. Okay, so we will have e to the x cos x dx. Okay, okay, still okay, I think. And then same way we write u, and then du is e power of dx ax dx. D phi is cos x dx. So phi is sine. Okay. Still write all the questions, all the equations. And then u phi now becomes ex sine x, right? And then minus the phi du from here, sine x ex, so ex sine x. Okay, now look up this. Okay, now why do you need to write all the equation? Because we can solve this and we can move this to the left side. Okay, and we can stop the endless integrations, right? Okay, so we can have 2 ex sine x dx, and we can have the answer is, we can write half Let's write ex and then sine x minus cos x, and then don't forget to plus c. Okay, we can stop that, and this will be our result. Okay, so whenever you find integral that has some cycle, either it's e or trigonometric, you need to write all equations. Okay, sometimes you can get the original part of the equation and you can solve it. Okay. Okay, let me give you maybe one more example. One more example is x squared sine 3x dx. Okay. So sometimes if you use integration by parts, sometimes you need to repeat several times until you get the answer. If you feel it will be a cycle, then you need to do like the previous one. Okay, so the idea of this integral is if you have a power function and trigonometric functions, the one you need to put on to be derivable will be the power functions. Okay, will be the power function, because if you take that in the integral uh, as dphi, you need to integrate as dphi, then you will have x cubed, right? And I think that will be uh, getting more complicated integral at the end. Okay, so my suggestion is take this x squared as u, then you have du is 2x dx, and take dv as a sine 3x. So you can have v is negative cos 3x over 3. Okay, and I think we can solve this. So uv is and phi du is minus, so we have plus here. Phi du is 2x over 3 cos 3x dx. Okay, let's move out the constant. Move out the constant here. 2, sorry. And take the other u as x and other dv as cos 3x. So we have, this will be 2 over 3 x sine 3x over 3 minus v sine 3x over 3 dx. Okay. And I think this can be solved, right? This will be minus cos x, so plus 1 over 3 cos 3x over 3. Think that way. Okay, so it will be minus x squared cos 3x over 3 plus 2 over 3 x sine x over 3 plus 1 over 9 cos 3x plus c. A little bit complicated in terms of the form, right? Sine 3x dx. Now, if you want, you can try by yourself and try to develop this method. The question is, can we simplify this method? Okay, the answer is we can. Okay, we can simplify. Let me write how to do it and maybe explain more next Friday. Okay, let me write here. We call this method is DI method. Okay, not sure whether other professor also give this method or not. It's not in the textbook, but it's actually the same method as integration by parts, but we are just simplifying the method. Okay, so we are writing as D and I. D means unit differentiate, and I for the integral. Because you know that the form on integration by parts will have the form that one element will be differentiate, one other element will be integrate. Okay, so we are having a table that is, we are going to differentiate the x squared and integral the sine 3x. Okay, let me write the solution here, the formula. Notice that you have plus and minus, right? So every time you are differentiate and integrate, you need to multiply with positive or negative. Okay, so if we have this, write down the plus here. Okay, take derivative to x, 2, and then 0. Okay, we integrate this, becomes minus cos 3x over 3. Oh, I think we need to have more space like that. Okay. And from minus cos, we go to minus sine. 3x and become 9, like that. And eventually got cos 3x over 27, right? And this is plus, minus, plus, minus, okay? And we multiply, cross multiply this, okay? So we will have plus multiplied by x squared multiplied by minus cos 3x over 3. That's our first element. The second element, minus multiplied by 2x multiplied by negative sine 3x over 9. And then plus multiplied by 2 and then cos 3x over 27. So we can write down this becomes negative x squared cos 3x over 3 plus 2x sine 3x over 9 plus 2 cos 3x over 27 plus c. Is it the same? The same, right? Okay. So that's how you can simplify your integration by parts. Very easy, very simple. And even the previous one, the ex sine x, you can also use this one. But you need to stop at some point, and then you need to rewrite and solve the equation. Okay? So it can be used in all integration by parts. It's called the DI method. Okay, hopefully this can help. Hopefully this can help. Okay, now this is the end of our session. We will have a feedback time. We will have a feedback time about the chapter 6. Okay, so around just 3 questions. Okay, QR code. Wait for a moment. Okay, QR code. Let me go back. Okay, this part, this one, the above. Okay. If you haven't scanned the QR code. Okay, so we will have the feedback time. So I will stop this presentation and I will move the and let me take the okay, scan the QR code and we will have our feedback. Okay, it's just around 3 questions. Each question maybe 2 to 3 minutes. Okay, so hopefully you can join. Okay, hope you guys ready. Okay. Okay, let me check. Okay, I think we can start. 3, 2, 1. Is the answer is false. Okay, the answer is false. Okay, good. Okay, next one. Okay, ready? Okay, ready? Three, two, one, start. I hope the time is okay. I hope the time is 3 minutes. Will be okay. Okay, it's 9. Okay. Only one person who okay. Okay. Let's go for another round. Okay, three, two, one. Okay, let's start. Okay, so you need to write the answer in a fraction. Okay, fraction. Remember, and you don't need to write the pi. Don't need to write the pi. I hope the time is enough. Okay. Okay. 5 seconds. Okay. Okay. Yeah. Okay. Good. 23%. Okay. Yeah. Congratulations. Okay, that's it for today, class. See you next Friday, and probably we will have another quiz. Another quiz. Okay. So see you next Friday.